Hello, everyone. My name is Francesco. I'm the CEO and co-founder of Phoenix Security. But today I wanted to walk you through a new approach on solving vulnerability. We've seen CVE, we've seen volumetrics on common vulnerability enumeration. That is the word for CVE. But this has caused an enormous alert fatigue in user and organization alike. So I've spoken to many of our clients and I've spoken to many people, and I've been in this industry for more than 20 years to see that this has caused an enormous alert fatigue. So to solve this problem, we're looking at a new approach on vulnerability management that is basically called a threat-centric approach on vulnerability management. Now, on this approach, we wanted to really focus on the root cause of a problem. And to do so, we need to dissect the vulnerability, where they come from, how software is built, how software is shipped and organized. And it's a complex environment. So if you haven't had experience on the full SDLC or software development lifecycle, you normally wouldn't have an overview of what software it is, where does it get built, how does it get shipped in the cloud or on-prem. And normally what you will normally do is looking at the criticality of a vulnerability, deciding if it's exploitable or not based on some sort of threat intelligence information or information that you might have, and then deciding, do I fix it, do I don't fix it, or do I suggest everybody to fix accordingly to the service level agreement that is usually referred as SLA, and those SLA are traditionally flat across a number of vulnerabilities. Now, this approach has caused an enormous amount of fatigue in engineers and security professionals alike. So we're here to present a new approach called a threat-centric approach on vulnerability management that really focus on the source of vulnerability rather than solving each vulnerability individually. Now, to approach this problem and to really explore in depth why this problem is here and how to address this vulnerability, we're going to take two vulnerability as example. We're going to take Log4j as a well-known vulnerability, 2021 44228, and then QNAP NAS vulnerability, that is 2021 again, 28799. Now, on both of these vulnerabilities, those vulnerabilities were exploited at scale, made the news, made CISA and other vulnerability exploit databases, as well as were widely used in ransomware attack and cryptojacking. This is basically the way attacker address, or that is the way attacker have targeted organization to deploy ransomware or further exploit alike. So without further ado, let's dive deep on this analysis and let's see why root cause analysis is such an important problem to solve and how to approach vulnerability management with root cause analysis campaign and focusing on the vulnerability matters. I'll see you on the other side. Now, to go about this problem, we're gonna explore fundamentally where the vulnerability are. And in recent years, for a reason or another, take it more declared vulnerability, take it that there have been more vulnerability exploited, more software exploited, we've seen a trend going up of vulnerability exploitation. And we might hit the million vulnerability around 2030 very soon, or fairly soon. But this year, 2024 and 2025, actually the number of vulnerability have been higher than what we see here. We've seen 40,000 and more vulnerability. Now, to see the root cause of a vulnerability, we need to approach the problem in two ways. The first way is fundamentally approach the problem with CVE, CWE, CAPEC, MITRE, and TTP, all the way to threat actor. This is fundamentally to create from a specific CVE the class of vulnerability that is the CWE, the typology, and again, classes of vulnerability called CAPEC, and then the MITRE attack or the relevant attacker indicators that then can map to threat actors and who is actually performing specific ransomware attacks or specific targeted attack. Now, in all of this scenario, there is also cyber threat intelligence that can help us identify which are the CVE that are exploited at scale, or CVE that have exploited vulnerability, or threat actors that are active for specific vulnerability. The approach is fundamentally twofold. But if we see the software and the threat intelligence for software vulnerability, this is really not the right approach, because there isn't a direct mapping between CWE and CTI. That is traditionally where software comes about. Now, for certain libraries built in software, CVE is better. Now, the challenge with CWE, and I've taken just an example of few of them, is that there are a lot and they are quite complex in terms of structure. I'm going to touch on the structure in a second, but if we just take path traversal, that is just one class of vulnerabilities, you can see there are nuances. Now, this is great for mapping CWE into CAPEC, into threat actor. So if we take fundamentally, if we take the first vulnerability that we discussed, the QNAP vulnerability, that was fairly bad vulnerability at scale, because easy to exploit, easy to attack, remote code execution and easy to exploit, we're going to see them not just by the attack vector and the vector complexity, specifically the privilege required and the remote attack, that were two indicators that this vulnerability was bad. But then if we look at it on the mapping side, we have two indicators of vulnerability that are mapped to several other vulnerability score, that are mapped to several other TTPs. So if we just take the first category of vulnerabilities, we see a lot of mapping to threat actors. Now, this mapping is quite complex in itself. And if we take the MITRE attack mapping, this is the relevant stages of an attack that can be identified with MITRE attack. But if we start with the first classification of CWE, in itself is a quite complicated concept. Now, if we take the CWE in itself and trying to analyze basically what are the threat actor, and vulnerability affected, there is a lot of complexity around trying to remap one vulnerability to the likelihood of exploitation, to the threat actor in the campaign, the CWE, CVE, and then the classes, category, and views that CWE has. So to simplify the approach, if we go back, we are proposing a new method and a new approach to simplify CWE, still maintaining the full mapping so that CWE can be left there and you can trace fundamentally CWE to CAPEC, to TTPs, and so on, so that you can see fundamentally which threat actors are attacking which vulnerability classes or which method are they using. And we are going to use machine learning methods to, or an LLM method to fundamentally compensate this mapping. But from a folks perspective, if you're looking at the vulnerability description and if you decide, should we address this vulnerability or not, the couple of questions that you should ask is, how bad is this vulnerability? What are the common methods that are used in attacker remote code execution and similar attack methods? And are these going to be affecting me? What is the likelihood of exploitation? Now, if we go back and review the first type of vulnerability or the first CWE, so for this one, for the 2021 28799, that was the QNAP vulnerability, we take the first class of vulnerability, that is the pillar for improper access control. Now, this pillar in itself is mapped to a number of other categories that are why CWE are complex. OWASP top 10, 2021 and 17. We can ignore safely for now 17 because they are older. But if we take 2021 broken access control versus improper access control, is a slight nuance. You also have the classes of, or the view for typical software vulnerabilities and the category as well. Now, you can see why CWE is so hostile also complex in terms of mindset to review. So one of the approach that we are taking nowadays with Phoenix and in general that we are trying to approach is trying to simplify in this macro category of issues, because the granularity is great to do the mapping, but prevents everybody from a vulnerability management perspective to look at the problem and really understand, is this bad, is this good, do I need to action it or not, and what is the likelihood of this class of vulnerability to be exploited by different categories. Now, if we take just this, and if we apply this more simplistic approach or more simplified approach, that is basically the LLM output of this particular model, as you can see, we export vendor product, but most importantly, weakness, attacker, impact, and vulnerability type. So if we take this approach back to the vendors and the version, what we're interested is, for this particular aspect in this particular video, the weakness, the impact, the vulnerability type, to fundamentally take this vulnerability into a more simplified class of vulnerability. So if we take this one, this is a remote code execution with broken access control. That's it. Now, if we look at the analysis of a lot of these classes, and I'm going to show a little bit this later, memory corruption or broken access control of the like, and remote code execution are the majority, from a technical impact perspective, vulnerabilities that affect the full vulnerability database. Now, if we see as well this into the analysis that we did as well, and all of this diagram and analysis is available on the website link below, or if you scan the QR code, but if you don't try scanning QR code out of the internet, and I will trust you if you're a security professional, this is, I'm going to put the link on the website below. But if we take elements like remote code execution or buffer overflow, as a consequence, those again could be reconnected to what we were analyzing before in QNAP as a vulnerability, because those are the two methodology types. In reality, it's slightly different for QNAP because it was a memory corruption issue. But again, if we see the classes of vulnerability, for example, in 0 days that are more frequent, remote code execution and memory corruption as a consequence are very frequent. So we can take and we can go forward on looking at, from a technical impact perspective, for all the ransomware attack on our cyber threat intelligence. You can see that remote code execution, again, in QNAP in this particular case, were very prevalent in the vulnerability exploited by threat actors, as well as input validation and memory corruption. Again, those are very relevant and prevalent vulnerability classes that are exploited at scale. And if you want additional confirmation for remote code execution type of vulnerability over the years as well, for CISA-KEV or CISA non-exploited vulnerability, this is the study that CISA, the Cybersecurity Agency for Infrastructure in the US, has done over the years and has explored this vulnerability. And these are the top 30 exploited for every year, 2021, 22, 23, and 24. And if you want additional confirmation, again, memory corruption and code execution or remote code execution in this particular case, because the code can be triggered remotely, are more prevalent. Now, this is why I particularly like this view of vulnerabilities, and to look at really the root cause of the vulnerability as the classes of vulnerability that you have. Now, if you look at the classes of vulnerabilities, what you will probably do is analyzing how bad a vulnerability is, and this is an example with Phoenix Security that brings together not only the classes of vulnerability, but also the type of vulnerability, all the CTI that is affected by it. And then you can look at the root cause analysis of like how many systems are affected by this particular vulnerability, and can we solve this particular vulnerability at scale with a focused view on this. So that's what we normally call a root cause remediation campaign. So looking at a systemic issue, how much vulnerability, how many findings are affected by this particular vulnerability, what is the aggregated risk that this particular vulnerability brings to the table, and how can we solve and eradicate this particular problem at scale eventually if this particular issue is identified, and who carry that particular risk across our organization. That is the topic that we're going to touch point in a second. But just to recap, we have a vulnerability. Traditionally, we will say fix this particular vulnerability with SLA X, Y, and X. But we're not looking at the root cause of problem, that is this particular class of vulnerability that affect this particular issue, that is the QNAP vulnerability, exploited at scale by threat intelligence, by the likelihood of exploitation, or by the classes of vulnerability that are more exploited at scale. And again, in the link, you're going to have the Risk Explorer, that is an open source project that we created to showcase the classes of vulnerability and the mapping and some of our threat intelligence that affects the particular threat actor, and how we map threat actor back to the vulnerability, and hence show which threat actor could potentially target your organization by the direct or indirect. In this, but those were direct link because there is evidence that these exploits are exploited by ransomware. Now, if we go by Log4j or 2144228 is a little bit more complex, so there are more classes of vulnerabilities mapped to it. One way is because this vulnerability was well studied, well analyzed, and hence there was a more granular approach on CVE. Take a note that normally CVE are not very well classified. So this is the full national vulnerability database that is documentation about all of this vulnerability, and only 50%, slightly more than 50% of vulnerability are actually classified to CVE, but not all of them are rightly classified. That's why we're reclassifying as well CVE with Phoenix Security. That is the result that you can see here by major category of vulnerability and with this vector analysis of vulnerability. Now, if we go back to the CVE, you can see that those CVE are classified by multiple CVE. So improper notarization is of the vulnerability. By the way, a little bit of a step back. So if we take this vulnerability, and I'm going to take a little bit of a step back, this vulnerability, Apache Log4j, was an injection attack that anybody could trigger with a specific string. I'm not going to go in detail. I'm not going to go in detail on describing the full vulnerability because that will take away the purpose of this video. And I'm going to have the link of the vulnerability if you want to see it here for the National Vulnerability Database. Again, this vulnerability was particularly targeted because it was easy to exploit with just a string, was widely distributed because Log4j is a library that is contained in a lot of software. And I'm going to touch on that in a second on the library side and why the library are so complex. But fundamentally, the attack complexity was low, there was no privilege required, and it was an attack based on a network perspective, as you can see here. So it was you could launch the attack remotely with a remote code execution. Now, if you look at this, you will see a number of exploits or category of exploit: deserialization, improper neutralization, and exploit of sensitive information through queries. Now, what does that mean is you can reconnect that back to an injection attack, and then remote code execution could be driven through an injection attack. And as you can see here, all of these CVE then map to these major categories of vulnerabilities that you can reconnect to fundamentally a more simplified version of code execution or access control. And as you can see here, the vector analysis for these particular vulnerabilities is fairly more simplified. Again, arbitrary code execution. The vector attack is through injecting a vulnerability, and improper access control and code execution. Again, you can see these particular classes of vulnerability. Now, if we ignore the CVE. And this is just one of the vulnerability exploited. Now, if we want to see that at scale, we can see that this particular vulnerability or this class of vulnerability, again, was used by this particular threat actor through the mappings. Now, we don't need to look in detail about this. Phoenix helps you fundamentally mapped from threat actors all the way down to CVE and CWE, but it helps categorizing and going back to the diagrams. The fact that remote code execution, again, and improper option and input validation are very much technique used by ransomware. So if you have a vulnerability that have these particular characteristics, then it's very important to take into consideration those characteristics as a high indicator that those vulnerabilities will be used in ransomware or by particular threat actors to exploit. Simply because remote code execution means that you can trigger the attack remotely, so the vulnerability is very likely to be used by attacker remotely. And then with memory corruption means that it can cross the boundary of memory, attack different level of system, permeate inside the memory, remain there, or input validation. It could prevent the traditional parsing of a string from the traditional method that leads to injection attack. So all to say that if we take a more simplified approach, we can then map back from the individual vulnerability to the CWE. That is what Phoenix help you doing by looking at not just the individual vulnerability and the likelihood of exploitation, your impact analysis on your system. So how bad this particular vulnerability is inside my organization, how widespread it is, which system are affected by it, which team are affected by it. And in general, when you look at Log4j, we start analyzing one vulnerability specifically, but there is a whole set of classes of vulnerability. So when you want to address a class of vulnerability like Log4j, you want to really look at where it is present, how widespread its presence is, which team are affected, which application and environment are affected by this particular class of vulnerabilities, and how to address it at scale. Now, the other method is, and we're going to touch this on a second, where the vulnerability manifests, because sometimes vulnerability like Log4j are directly included in operating system or in your library, in your code, or in your container, or all of the above. So the challenge is looking at a vulnerability, looking if the vulnerability is present in an SCA system or an OSS system, or an open source library, or container, or all of the above. So it's important to have system like Phoenix or any vulnerability management solution that will focus on root cause analysis to help you really addressing the root cause of a vulnerability like Log4j. Now, if we look at a vulnerability like a library, like Log4j, a Log4j could be included directly in a main piece of code, and we're not going to explore every single aspect of this, but just to illustrate why the system is complex and why solving even a well-known issue like Log4j is a particularly complex problem when you unpack it, and not just saying, hey, fix Log4j because of SLA, but looking deeper into the root cause of the problem and where that library manifests and how to address better that library is important. So if we look at Log4j, for example, that's a library. It can be directly included or it can be a transient dependency. When it's a transient dependency, means that you might include that particular library directly in the piece of code that runs, but then if it's a transient dependency, it means that that library is included in a library that you already included. So chances are that you will not be able to touch directly this inclusion or this vulnerability, but you need to upgrade the source vulnerability, the source library that you include. That's why transient dependency are a little bit more challenging to solve than direct dependency. Now, when you build a particular piece of software with Log4j inside, or you run a particular software that has Log4j inside, and was particularly with Log4j, as you can see, there are tons of systems that will have Log4j installed inside, and this is the CP or common enumerator for software. So a lot of these systems contain inside Log4j, and hence they were vulnerable to Log4j. And this is the challenge with vulnerability management. Not only you might include Log4j inside directly your system, but those systems there are other systems that might contain Log4j. So having a vulnerability management platform or a unified vulnerability management platform, an ASPM platform like Phoenix Security, that could tell you where Log4j is present or how widespread is Log4j presence inside your system is particularly important. Now, let's assume the simple scenario where we have Log4j directly integrated in a software that we can control. Where that particular library is deployed, it could be in a build file, it could be in an artifact that is already built, so we need to trace it back the build file where that artifact get built, or if we're lucky enough, we know exactly which piece of code through an SCA analysis like the one we do in Phoenix Security with reachability analysis, so we know that this code is actually included in the build file and not just declared in the particular line of code, include log4j, but then nobody calls that particular function, and hence the build file end up not having log4j. So if you scan the code in itself, and this is a concept called reachability analysis, we have other video that I'm going to post in the comments. If you have a code that called log4j, then that log4j will be in the build file. If you have not a code but an include, any system that scans the code in itself without reachability analysis will give you what we call a false positive. But let's assume we have an artifact that get built by a build file, and the build file get built inside the code, and log4j is actually used by the particular software that we're using. So that will end up in a container. In the most modern world, any piece of software that runs in your system will normally be included inside a container, and then the container will be deployed either in a registry, in an artifactory that is a store of images, or a container registry or a container image. Now, that image can come directly from how you build it, or it could come from any source that somebody else has published. So you might download a container, or you might build a container with another piece of container that has log4j. So the library might be inside a container that you download from an AMI that has, for example, log4j. So for example, if you run AWS Lambdas or AMI through log4j, Amazon back in the days, back in 2021, has declared, hey, we removed this particular vulnerability in this particular AMI on this in particular source. So let's assume the easiest scenario where you are building a log4j affected issue or a library that get built inside your SCA, that get shipped inside your direct container. Now that container then will run, and then that's called contextual reachability analysis. I'm going to, again, link a very deeper description of what contextual reachability analysis is and how we solve the problem in Phoenix to not fundamentally raise the problem 3 or 15 times, depending on how many times or where do you scan. But that container is the root cause of the vulnerability. If the library is directly contained inside this particular container, not the running container. The running container is a manifestation of that vulnerability that were sourced by the container in itself. And that vulnerability might have come from either directly the container that you build, or a source image, or a golden container that is basically your preferred source image. And that should be the way every container should be built. But again, we're not going to go inside that subject. And that vulnerability will have come either from the container or from the software you have included inside the container. Now, log4j was particularly nasty because it was a library used both in operating system for the container, so the OS layer of the container, as well as software that were included in a vulnerability. Now, if we take the particular point and problem of log4j, it was included in a number of software. Now, if you are in Phoenix, you can detect where log4j is and in how many system, application, environment, product this particular vulnerability is manifested on, and you can again schedule a campaign to solve vulnerability. Now, if you want to monitor fundamentally the status of Log4j in a system like Phoenix, you can see fundamentally your aggregated risk, your open finding, the number of findings, where those findings manifest, in which software they are represented, and how many tickets the people are fixing, or you can raise ticket with the individual team at a click of a button. And document all of that information into the system. Now, assuming that the root cause of the library was, hey, you have a particular SCA or a library in your system, that's good, that's golden. You can include that in your campaign and trace all of the library that normally you will have for Log4j. So the library you will normally have here, you will just address them, each team that actually has that library that are affected by that particular library, which component or which application is affected by that particular library. Now, if you are in the product land, so if you're building an AMI, as we've seen with Log4j and the AMI version in AWS, or if you're building a Linux system that has Log4j and you're running those endpoints as laptops and so on, or if you have an OS layer container image, those products will contain either the particular piece of software or the installed software, in particular this case could be containing Log4j. Now, this is why addressing vulnerability or trying to patch vulnerability or scan vulnerability in a running container, it's important to know that those containers are running, or a VM is running, or an OS is running. But we can't fix that into the running product. We need to know what is the root cause of the problem. That is either the image where those systems get built, the product where those teams, where those systems get built from, and that's what we call this root cause, or the software library where this particular problem manifests. So if a particular software has a particular library that will cause us an effect. Alternatively, if we have a particular piece of software that we build, and again, we need to determine if the container has the problem at the OS layer, or is the software that we build inside the container that has this problem. Now, to wrap up and to conclude, the scenario is complex. So traditionally, we tend to scan at runtime with a pen test or with a CSPM if you're running in the cloud, or an application security scanner or application security testing software that scans your system here or your system here. The value of a solution like Phoenix that is unifying ASPM plus CNAP that is basically tracing which software get built where, and if the software is running or your endpoint is running, or if it contains a software, and running a campaign or running a remediation is important, because enable your team and engineering team to focus on the real problem and where it comes from, not where it manifests. And to do so, it's important to look at the vector analysis of the vulnerability and looking at the major classes of vulnerability and where those vulnerabilities come from. So not looking at the individual vulnerability, but looking at the classes of vulnerability and what is the root cause analysis of the vulnerability to really focus on the source of the problem that is causing the whole issue. So I hope this was informational. You have as well on the website additional information on all of these sources of data and the classes of vulnerability that affect the traditional software in 0-day or the most exploited vulnerability, as well as you're going to have the link on the threat-centric approach and the matrix that connects the vulnerability to the CVE, remap, reclassify, and the newer version is coming with the LLM that categorize and provide you a description of remediation so you can do a deep code analysis for that particular vulnerability. This is Francesco. I'm the CEO and co-founder of Phoenix Security. I hope this was informational. All of the links are available in the comment. Stay safe out there and look at the root cause analysis so that you don't burn out. Thank you. Goodbye.